talk about an important key concept related to complex numbers. Guys, it is called the absolute value. We already know the basic definition for an absolute value. Guys, absolute value basically tells us the distance from the origin. In this case, we want to find the distance of the complex number from the origin. Guys, one of the ways to understand this concept is by actually plotting a complex number, and from there we can evaluate or we can figure out how to find the distance from the origin. Okay, guys, let us work for the general case, and then I'm going to share some examples with where we have values for real part and the imaginary part. Okay, so let us say we have, this is the standard form or the general form for a complex number, and let us start actually plotting this complex number. Guys, again, for convenience, let us say both a and b are positive. So a and b are both positive means greater than 0. So if a and b are both positive, and if we want to plot them, obviously they will both be in the first quadrant. Okay, so this is my real axis and this is my imaginary axis. Now a and b are both positive. Let's say this is my point A and this is b. So the point, this here, this would be my complex number z, represented by a coordinate pair a comma b, where a is real part and b is my imaginary part. Guys, that is how we plot complex numbers. So we identify the real and the imaginary part, and then we plot that point based on that information. So this is my complex number z equals to a plus ib, or you can also think of that as a coordinate pair a and b. Now let us go back to the idea of absolute value. We know absolute value is the distance from the origin. It is the distance from the origin, and we already know that it is always going to be a positive quantity. So distance from the origin, what does that mean, guys? It means how far is this point from the origin. Now we can actually connect this point from the origin, and if we find the distance of this line, that would basically give us the absolute value of this complex number. It's as simple as that, right? So by actually plotting it, guys, we are able to really see what we are calculating. Now, looking at this line and knowing the fact that one has to calculate the distance or the length of this line, guys, there's few different things that people like to do. One is that they already know the coordinates of the origin, which are 0 and 0. So you basically have to find, and we usually call it r, okay? So guys, sometimes people like to use what we call as the distance formula to find the distance between any 2 points in a coordinate plane. So if you remember the distance formula, then we can just go ahead and use the distance formula. But guys, it's not a big deal if we do not remember the distance formula. There's other easier way of doing it, which is if we do a simple geometric construction. So guys, if I drop a perpendicular from here and up to this horizontal real axis. So if I drop this perpendicular, then we can clearly see that this is a right triangle, and in this right triangle we already know that this distance or this length is a units, right? Because that is what the real coordinate is. It's a units here, so that means it is a, the distance is a for the horizontal or the real axis here for this right triangle, and the vertical length from this point up to this point obviously is going to be b, as already provided by the complex number z equals to a plus ib. So we have the horizontal distance, the vertical distance. Basically we have this nice right triangle. In this nice triangle we have the base and the altitude, or the height, however you want to consider this. And guys, in this right triangle, finding the absolute value basically means finding the hypotenuse of this right triangle given the other two sides or other two legs, however you want to call them. How do we find it, guys? We have our nice Pythagorean theorem. That's what's going to help us to actually evaluate that distance, or which in turn basically is the absolute value. So we know using the Pythagorean theorem, r squared is what? A squared plus b squared, sum of the squares of the other two sides. And to find r by itself, what we have to do is simply take the square root on both sides. And in turn, we know r is the absolute value of the complex number z equals to a plus ib, because we know absolute value is the distance from the origin, and r is actually representing the distance or the length of that line segment or length of that hypotenuse. So guys, absolute value, which is represented by these vertical bars, we already know that from our basic understanding of the real numbers and all the concepts related to real numbers. So absolute value of z is equal to r. We usually represent it with r, and that in for the standard form will be square root of a square plus b square. Guys, sometimes people just simply like to remember this as a formula. Guys, it is not such a complicated formula. It is just basically using the Pythagorean theorem, right? And the idea of the distance formula is basically similar to you actually doing the Pythagorean theorem. But guys, if you don't remember this distance formula, or sometimes we can forget things, then just draw this and then rely on the Pythagorean theorem. So this is how we find the absolute value of a complex number given a real and an imaginary part. Now let us do some examples with this. Guys, let me take an example one where I have a complex number. Let us say I have negative 3 plus 4i. Okay, and we want to find the absolute value of this complex number. We can just directly use the formula. We already have discovered the formula here. We basically derived the formula. So you can directly use the formula, or guys, you can also, if you like, you can also plot this, and from there you can actually kind of derive or figure out the absolute value by finding the distance of this complex number from the origin. Guys, in this case, let us go back and try to plot this complex number and then find the distance from that particular plot, okay? So let me get rid of this and we'll plot this complex number and then we'll go from there. So if I have to plot this complex number, obviously there is a real axis here, there's an imaginary axis here, and my real part here is a is negative 3, which is my real part, right? And then my b is positive 4. Keep in mind it is my imaginary part. And if I like to think of this as a coordinate pair, it is going to look like negative 3 and positive 4. And when I transfer this information onto the plot or to the graph, guys, it's going to be negative 3 on the left. So it is negative 3, let's say right here. And then 4 means I have to go 4 units up. 1, 2, 3, 4. So somewhere right here. So this is my complex number z equals to negative 3 plus 4i. Or if you like to, you can also write it as a coordinate pair, negative 3 and 4. Now, in order to find the distance from the origin, the very first thing I'm going to do is I'm going to just connect this point, the complex number, with the origin. And once I connect it, I can easily see that just by dropping a perpendicular from that point onto this horizontal real axis, what I have right here is a right triangle. And in this right triangle, we know this length is 3 units, okay? And this length is 4 units. Basically, finding the distance or finding the absolute value is just finding that length of that hypotenuse of the right triangle, which we can do easily by squaring the other two sides. So 3 square plus 4 square. Guys, keep in mind this is 3 units to the left, but when we think about the distance, we're just going to consider the absolute value, which is positive 3. So r square is this, and if I have to find just the r, because we are interested only in finding the distance, which is given by r, is going to be square root of 3 square plus 4 square. And when we simplify this, it's going to be square root of 9 plus 16, which is square root of 25, guys, which is just 5. So that means the length of the hypotenuse is 5 units, and that is exactly what the absolute value means. It is just the distance from the origin, which is represented by here by the length of the hypotenuse, which is r, and that is equal to 5. Guys, this is one of the ways to find the absolute value. You can plot it and then get it from there. Or if you now already remember, or we have this nice and simple formula, we can quickly just use the formula, which is square root of the real square, which is negative 3 square, and the square of the imaginary part square. And if I simplify this, negative 3 square is still going to be 9, because negative times negative is positive. So it is still 9 plus 16, and you will get the same thing, right? Square root of 25, which is 5. So guys, both ways you get the same thing, but this is like first plotting and then getting it from there. But you already understand the basic concept and basic things involved in actually finding the absolute value of a complex number, which goes back to actually plotting it and then finding the length of that hypotenuse. Okay, so if you remember all that, then guys, you don't have to every time you don't have to plot it and then find the absolute value. Whenever you are asked to find the absolute value, just directly use this formula. Okay, guys, this is an introduction again to the idea of absolute values. I'm hoping and expecting that you already know these basic ideas, but I still wanted to go over these concepts before we again kind of bring these things together to kind of see the trig connection or trig functions, how they are connected to the complex numbers. So guys, in my first video we introduced the complex numbers, how to plot a complex number, and now here we have the absolute values. In my next video, guys, now we are going to talk about the trig functions and how we can transform from the standard form of a complex number, which is a plus ib, to a trig form. Okay, till then guys, take care. I will see you in the next